Hey guys, we're going to go ahead and kick off week number 2 here. Hope everything's still going good. Miss you guys. Can't wait till we can actually be in a classroom again. It is really weird teaching to really nothing and no one, I guess. But making it work here, as I'm sure you guys are as well. Again, proud of the way you guys are getting your homework done and getting all your stuff taken care of. Really appreciate that. Today is the start of Zoom hours. Okay, so again, I have that listed as a link on Classroom, so if you need to contact me during my Zoom virtual office hour, you may do that. Otherwise, today we're going to go ahead and look at segments. So the other day on Friday, we worked with the angles with these. You guys worked with the angles and you worked with the arcs. Now we're going to look at these segments. I will make a couple changes to the notes here as we go along. And again, remember, there's always changes to the assignments now to kind of shorten them up a little bit and kind of keep it to the basics. So make sure you always check the assignment under the learning target and daily agenda, not the one in your packet. Okay? So if you look at what I got here, we've got the inside, you've got your two chords intersecting. Each of these little pieces, they do call chord segments. Okay, so just kind of part of the chord, what it gets broken up into when they do intersect each other. Okay, and whenever we're working with these, what we can do is we can multiply the pieces of the same chord. Okay, so we're going to find the product of the chord lengths are equal to each other. So for example, A and B are part of the same chord, so I could multiply those and they will always equal C and D. In other words, it does end up being proportional. We just kind of skip the proportion part and go right to the cross multiplying part. Okay, so for example 1, that's what we're going to be looking at today. So for example 1, kind of have a picture similar to this one, but we'll redraw it a little more like the one you guys have. Okay, so if you look at this one, you've got 4 and 15, and then you've got 6 and X as your pieces. Okay, so again, just going to multiply the two pieces of the chord and solve those. So I'm going to take 6 times X equals 4 times 15. Okay, 4 times 15 will end up giving you 60. Divide by 6 and we'll get X equals 10. Okay, so again, anytime they're on the inside like that, we're just going to multiply the pieces together. Now we're going to do the same thing on example 2, but example 2 will require us to distribute / FOIL. I'm not going to have a ton of these ones, again, just because I'm not really there to help you guys quite as much. But this is something we've been doing all year, so we should be good on. Okay, so you've got the, again, intersection here of the two. Okay, we have X and X plus 2, X plus 6, and X plus 12. Okay, so again, same idea as before. We're going to multiply the pieces of the same chord. So we're going to take X times the X plus 12. Again, have to have parentheses there. And then we're going to take the X plus 6 times the X plus 2. Okay, this side just normal distributing. You'll get your X squared plus 12X. This side we'll have to make sure you distribute / FOIL. Okay, so X times X will give you your X squared. X times 2 would give you 2X. But then you're also going to get a 6X here, so together that would give you an 8X, and then the 6 times 2 will give us 12. Nice thing you're going to notice is your X squareds are going to cancel out. You have 1 on each side, so we would subtract those away. So now it really just turns into a normal problem from here. Subtract your 8X to the other side, divide, and you end up with X equals 3. Okay, so that's if they meet on the inside, that's what we're going to do. Okay, now let's talk about what if they meet on the outside, like with our secants and our tangents. Okay, we'll have a formula for those as well. It will be just slightly different. Okay, the first one we're going to look at is if I have, example 2 we're not going to do. Don't worry about example 2. We don't need that one right now for us. Okay, so we're going to jump down to the secant part. So you'll notice it says secant segment. Okay, it's part of a secant with one endpoint on the circle. Okay, so it's going to be a little bit different because it won't be a line. Okay, it will actually end. So it'll be something like this would be considered a secant segment. Okay, where one of them keeps going, the other one actually stops on the circle itself. Okay, and then if we have two of those, that's what we're going to be working with on our next example, okay, our next theorem. Now you'll notice they have something called an external secant segment. That means they're just talking about the part on the outside, so that would be like these two little pieces would be outside ones. But if we talked about the whole thing, then we would just call it secant segment. Talking about the out part, we call it external because it's on the outside. Okay, so when we work with these two secants, this is our next theorem here, the intersection, like I said, is outside of the circle. Okay, we still want to label our pieces though here. Make sure I label them the same as what I kind of have in my notes here. So you got the four different pieces you're working with. When we're working with these, how you figure it out, or the proportional way that they are cut, is it's always going to be the outside times the whole equals outside times the whole. So the outside on this top one would be B. The whole thing would be adding these two together. So I would have to add the A and the B. And then I'll do the exact same thing for the other one. So the outside is the D, and then I would add the two to get the whole thing. Okay, so that's the formula we're going to use anytime you have two secants that are meeting on the outside, okay, of our circle. All right, so let's go ahead and look at a couple examples with that, with example 3. So the first one you have on example 3, and it looks like this. We have x and 9, and we have 4 and 5. Okay, anytime you do have the variable on the external part, we are going to be required to probably factor unless it cancels out. This one will factor. Not going to give you a lot of factoring ones, but if we do, they are numbers that work out pretty well for you. Okay, so I'm going to take the outside, which is the x, times the whole thing, which is the x plus 9. On the bottom, same idea. The outside is the 4. The whole thing would be 4 plus 5, so we can just go ahead and write that as 9. Okay, so normal distributing on the left side, so you end up with x squared plus 9x. On this side, you'll end up with 36. Notice you got an x squared, you got an x, so we can't use the square root method. We do need to factor. So you'd want to bring the 36 over to the other side. And then we can go to our two sets of parentheses because there is no GCF. Again, if we're going to factor, they will be pretty nice ones for you guys. A lot of them won't have factor. They don't have to. Okay, so the factors we'd want to use would be 12 and 3. We'd want a positive 12 and a negative 3. Okay, set those equal to 0. You'll get negative 12, but since x is a segment, we can't keep that one. So we'll just end up with x equals 3 as the one we will keep as our final answer. All right. So if we look at the next one, then the next one does not have factoring in it. Okay. Again, most yours are going to work out pretty well. You may have a fraction here or there. We will end up with a fraction in the next one, but you don't have to. Just kind of one of those things that will happen on this one. So for this one, you got 12 and 7. You got 6 and x. You'll notice the x is on the inside part. When that happens, then you won't end up having to factor. So same idea as what we did with the other one. I want to take the outside times the whole. So the outside is 7. The whole would be adding those two to get 19. On the bottom, I get 6. And then it would be an x plus 6. Because can't actually combine those two together. So from here, we'd go ahead and just do normal simplifying. Okay, so if you go ahead and multiply 7 and 19, 6x plus 36, let's see, that would be 20, would be 140. So 133, I believe it is. Hopefully that is correct. Okay, you can subtract your 36 and get 97 and divide by 6. Again, we still don't want to round, so we will just leave our answers 97 divided by 6, which again is fine. We can end up with answers like that. All right? So that takes care of if we have two secants. Okay, the last situation we're going to talk about is what if we have a secant with a tangent. Okay, we've actually already done two tangents before. The two tangents we did section 10.5, I believe it was, because if you have two tangents, they're just equal to each other. Okay, so we just set those equal. But what happens if we have a tangent and a secant? Okay, so for the next one, okay, we're going to have one secant, but then we're just going to have a tangent. Okay, where it just stops right there. It does not continue on through the circle. Okay, so what you really end up with then is you only end up with a couple pieces. So I've got A as the tangent piece here. Okay, I'm going to go with C and B just so it kind of matches the same letters I have on the filled out notes for you guys. Okay, so same idea with the secant. We're going to take the outside times the whole thing. Nothing changes there. The difference comes in with my tangent is I don't have two pieces. So what we do is we just square the piece we have. Okay, so it's just going to be A squared. I just basically take it times itself. That kind of gives us the two parts that we want. Okay, so this is a formula then we're going to use, okay, when we work with the tangents. So let's go ahead and look at an example with this. Now I am going to change example 4. Example 4 as it is going to require you to use the quadratic formula, which is something we were going to review in class. Obviously we can't do that, so I'm not going to make you do that. Okay, so we will not use quadratic formula on your homework either or anything like that. Okay, so I'm going to change it here. I'm going to go ahead, let's make this, hopefully these numbers work out okay. I'm going to make this 10, I'm going to make this 4, and I'm going to make this x. Okay, so again, change the problem that's in your packet to match this one. Okay, so we want to go the same idea, the outer times the whole thing. So 4 times 4 plus x would equal, the tangent we're just going to square, so it's just going to be 10 squared. Okay, which if you want to simplify to 100, go ahead. Okay, and then from there it's just your normal solving. So I'd end up with 16 plus 4x equals 100. So we'd subtract, we'd end up getting 4x equals 84. So we'd end up with x equals 21 for that one. Okay, so again, kind of the same idea, just if you only have a tangent, go ahead and square it. Alright, so that's it for today. You'll notice there's one more example at the bottom. I'm going to go over that one tomorrow. Tomorrow we just have a worksheet reviewing Friday and today. So I do want to do that one first with you though, just to kind of talk you through it. Otherwise, I hope you're doing great. Can't wait to see you guys again, and have a great day.